Hi there, my fellow stats enthusiasts. I'm so glad that you decided to join me for this screencast. It's not actually one that follows in sequence with the screencast that I'm making for the OER project, but it is a topic that I think is useful, and it does belong to the subject that I teach, which is statistics. Um, and I think it is something that you'd be able to use in your everyday lives, or you'd be able to use in work or in your studies. Pareto analysis is a prioritization tool. So I've decided to make this screencast and make it available as well with all the rest of the OER screencasts. For those of you who are joining me for the first time, my name is Bronwyn and I lecture statistics, applied statistics at CPUT, and I welcome any feedback that you might have to any of the screencasts that I make, and you are more than welcome to email me at swatsb@cput.ac.za. In terms of the screencast, please feel free to download it and share it with your friends. Watch it as many times as you want to, and tell everyone about the OER project that we're having at CPUT. So let's get started. So Pareto analysis is a statistical tool, and it is, I'll give you first a bit of a background. It is a tool that we use in the field of quality, which is actually the program that I lecture on. I lecture quality, and it's a tool that we use to prioritize. And if you are not certain, you've got lots of sources of problems. It could be sources of problems, but it could also be tasks that you have to perform. Anything, a list. Say if you have a collection of things and you need to prioritize and you're not quite sure where to start, and sometimes in lots of data, you've collected data on this collection of items that you have numbers or categories, and you have counted the number of times that a particular category has come up, and you're not sure where to start, then you would use Pareto analysis to help you prioritize. And Pareto analysis, the principle on which this analysis is based, is from a gentleman by the name of Alfredo Pareto. And what this gentleman did in Europe many, many years ago was he studied the distribution of wealth in Europe. And what he found was that 20% of the population in Italy was actually, they were actually in possession of 80% of the wealth. I've also heard a similar story where he said the idea that initiated the study was in his garden he had pea plants. So and in the pea plants he noticed that 20% of the pea plants, the little individual plants that he had, was actually producing 80% of the peas. And he wondered how transferable this principle was to other things. And what subsequently happened is, as more people did research, they heard about this principle, more people did research, and in the field of quality, which is what I lecture on that program, they found that this principle could actually be applied to problems. So if you have problem sources that give rise to actual problems that you see either at your work or at home, you would find that 20% of these problem sources actually give rise to 80% of the problems that you see and that occur. And if you fix 20% of the sources, the vital few, then you will get rid of most of the problems, and the other problems are the trivial many problems. The remaining problem sources are the trivial many, whereas there just are a vital few that give rise to most of the problems that you find in your area. So it sounds as if I'm waffling a bit. So let me continue by showing you what a Pareto graph looks like. This is what a Pareto graph looks like, and this might illustrate my point a little more. As you can see on my graph, my Pareto graph, there are four. These are problem sources. So these four problem sources, as you can see, these problem sources give rise to actual problems, which I've labeled here are defects. And problem source number one, the graph, this graph that I have here shows that problem source number one actually gave rise to the most defects, whereas problem 2, 3, and 4 did not. And so this is what a Pareto graph does. It very, very quickly communicates this information. And if you need to communicate this information and know beyond a shadow of a doubt that what you're doing, if you need to prioritize, is the right thing, then Pareto analysis is the way to go. So I'm going to start by listing the steps of Pareto analysis. And this might still sound like a bit of waffle, but do not be intimidated. I'll list the steps first, and then I will explain each step, step by step. But before we start, know that there are 7 steps to doing a Pareto analysis, and these steps are: first, arrange your data in descending order. In fact, there's a step before that, which is collect your data. But of course, we know that we need to do that. The next step is calculate the percentage for each problem. Then you calculate a cumulative percentage for each of these problems. Then you plot the problems on the x-axis, and then you plot the individual values related to each problem on the y-axis. And I'll explain that as we go through the example. Then you plot the cumulative percentages on the right-hand side y-axis and draw a cutoff line. Now, for those of you that are really sharp and on top of your game, I've spoken about the y-axis here in step number 5 and a y-axis there in step number 6. And the nice thing, this is what I tell all my students, is what I like about Pareto, besides it being a fun and easy tool to use, it's a buy one get one free special. You know, like when they have sugar on special at Spar, sometimes if I don't need the special, even if I don't need sugar, if it's buy one get one free, oh, I'm going to buy that sugar. And so Pareto analysis is like that. It's buy one get one free because it has one x-axis and 2 y-axis. Okay, so let's do this example and everything will become clearer as we progress. The first thing that we've done, now know that you can again use this for any example, anything that you need to prioritize. You could be coming late to work every morning and you're not sure where you should start, what you should start focusing on to try and fix that. It could be maybe your clothes aren't ironed, your alarm clock doesn't go off, you're taking to lunch to long to make your lunch, and so you could collect data, gather data on these problems that you see. But for the purpose of this screencast, I'm going to use a restaurant example. So pretend I'm a manager of a restaurant and I find that my customers are unhappy and I want to make my customers happy, but I need to know what is the first thing that I should look at, where should I focus my efforts so that I can get maximum output for the least amount of effort. And Pareto is going to guide me and show me where I should focus my resources. So I collected data from my customers over a period of a week, and this was the data that they gave me. I found that I had 105 complaints on cold food, 2 on flimsy utensils, 10 on food tasting bad, my salad wasn't fresh 94 times, poor service 13, greasy food 9 times, lack of courtesy 2, and lack of cleanliness was 25. So step number 1 was to arrange it in descending order, which is that I did over here. Now, what I need to then do is I need to actually, to be able to calculate the percentage, which is the next thing that I need to do, I actually need to tally up the amount of problems that I have. And when I do that calculation, I find that I have 200 in total. I have 260 problems. But notice how I put the most problems on the top of my list and the second most second on my list, third most third on my list, and so on and so on and so on. But I need to have this value in order to calculate the percentage. And of course, we know how to calculate the percentage. The percentage is, well, of this, for example, would be 105 divided by 260 times 100. And I'm going to do that for all of them. So once I've done that for all of them, then I could display my data in a table like this. So that once I calculated the 105 divided by 260 times 100 gave me 40%. Now I've rounded this off because it's logical to work with rounded off figures. Um, the 94 divided by 260 gave me 36%. The 25 gave me 10%, and so on and so on and so on. And ultimately, I then work out another column, which is the cumulative percent. The cumulative percent means adding them all together to give me a cumulative total of 100%. If I add all the problems obviously up, it would be 260 problems, and in total that would be 100%. So the cumulative percentage to work that values out, we'd say the 40%, and I add the 36% of the next one to give me 76%. The cumulative percentage of the first three would be the 40% plus 36% plus an additional 10%. Cumulative percentage of the first four would be the 40 plus the 36 plus the 10 plus the 5 until you get to 100. If at this point, when you've added the last problem and you are not at 100%, you know that you've done something wrong. You could be at 99% or 101% depending on the way that you round it off. But certainly for sure, if you're at about 120% at the end of adding up all your cumulative percentages, then you know, you've got to go back and you've got to see where you've done something wrong. So that takes us to step number 4, where we start plotting. Now let's quickly remind ourselves, what were the steps? Step number 1 was arrange in descending order that we've done. The step number 2 was calculate the percentage for each problem. And step number 3 was calculate the cumulative percentage. Now what we've got to start doing now, we're going to start plotting. We're going to start doing our graph. We're going to put the problem sources on the x-axis, and we're going to start with the highest on the left hand side. Then we're going to do the two y-axis. I see that I'm going to run out of time for this screencast. So I think I'm going to end this screencast here, and when we start the next screencast, or when I start the next screencast, then I'm going to continue with step 4 and 5 and then 6 and then step 7. So I'll see you in a bit. Catch you on the flip side.